Hello everyone, my name is Madhu Chawda. Welcome to my YouTube channel. Today we'll discuss about assignment 5 clustering for introduction to data analysis data 1200. In this assignment we are using the data set of Liu analysis new. So for that we have independent variable and dependent variable. So variables are cellularity of marrow clot section, which is independent variable, smear differential percentage of blast, infill, the percentage of absolute marrow leukemia cell infiltrate, Li, percentage of labeling index of the bone marrow leukemia cells, blast, absolute number of blasts in the peripheral blood, temperature, highest temperature prior to start of treatment. Dependent variable is remis. Remis 0 means no remission, 1 means remission. So problem statement of the assignment. So we'll perform and explain elbow and silhouette methods to understand the required number of clusters to optimize the k-means model. Use the dataset Liu analysis new.csv to perform the methods. Create two cluster visualization from dataset. Identify and present two key insights from two cluster visualization. So let's go to Jupyter Notebook for understand the coding part. First step to load the libraries. So we are loading pandas and numpy. So import pandas as pd, import numpy as np, then import matplotlib.pyplot as plt to plot the graph percentage matplotlib inline from sklearn.cluster import k-means from sklearn.matrix import silhouette score. So second step is to dataset, load the dataset. So our dataset name is Liu underscore data. So we'll be using pd.read CSV function to read our CSV file. So our CSV file name is assignment 5 Liu analysis new. So we'll use the dot head function to load the data, Liu data dot head. So you can see the dataset as below: cell, smear, infill, Li, blast, temperature, and remis. Now we'll create x variable. So for x variable, we'll be using all the cells apart from remis column. So we'll drop the remis column. So for that one, we're using dot drop function from numpy, and we'll convert that all the data to numpy. Second step is to scale the data. So for scaling the data, we'll be using from sklearn.preprocessing import standard scalar. So we'll be importing standard scalar, and when we assigning standard scalar as SC. So SC is equal to standard scalar. So we'll be using data transform. So is data transforms is equal to standard scalar dot fit transform. So we'll be using fit transform to scale the data. Next step is to determine optimum number of clusters using elbow method. So for elbow method, we'll be using WCSS within cluster sum of square. So let's see the coding part. For I in range 1 to 10, k means is equal to number of clusters n clusters is equal to I, and max iteration we will be using 300, and random state is assigned equal to 16. So after the for loop, we'll be assigning k means dot fit into data transform. So our cell WCSS within cluster sum of square will be added with the inertia dot append with the dot append function. So plot elbow method. So for plotting, we'll be using plt dot plot from range 1 to 10 and WCSS, and marker will be O. So plot dot title, the elbow method, plot dot x label, number of clusters, and plot dot y Y label means WCSS will be showing the graph as below. So optimization of k-means model using elbow method. So elbow method is most popular method for determining the optimal number of clusters. The technique is based on determining the within cluster sum of squared errors, WCSS in short, for various number of clusters K, and choosing the K for which changes in WCSS first began to decline. The elbow point in the curve will decide the number of clusters to optimize the k-means model. As per the elbow method, plot two plot two clusters are required to optimize the k-means model. As we can see, the elbow curve starts from cluster 2. Now let's go back to coding to understand the silhouette method. Create silhouette coefficient. So we'll be using a empty cell of scores. So we'll be running one for loop for n cluster in range 2 to 10. K means is equal to k means, n cluster is equal to n clusters dot fit x. We'll be using label as k means dot labels. Sil coefficient is equal to silhouette score. Inside the bracket data transform label and matrix is Euclidean. Now we'll append the scores with sil coefficients and print the cluster statement. So now plotting the silhouette method, plt.plot range 1 to 10 scores, then plt.title the silhouette method, plt.x label is number of clusters, plt.y label is silhouette coefficient. Now we'll show the plot with plt.show function. So as you can see, for n clusters, number 2, the silhouette coefficient is 0.22. Like that, there is a maximum number for number 5, the silhouette coefficient is 0.28. That is the maximum coefficient number. Optimization of k-means model using silhouette method. The silhouette coefficient is a measure of how similar data points is within cluster compared to other clusters. The equation of calculating the silhouette coefficient for a particular data point is Si is equal to Bi minus Ai divided by max in bracket Ai comma Bi. So Si is the silhouette coefficient for the data point I. Ai is the average distance between A and all I and all other data points in the cluster to which I belongs. Bi is the average distance from I to all clusters to which I do not belong. As per the silhouette method, 5 clusters are required to optimize the k-means model. As the 5 is the highest cluster point as per the graph. Now we'll understand how to create two clusters visualization. So for that one, we'll be applying k-means clustering. So k-means equal to k-means and cluster equal to 2, max iteration will be 300 and init equal to 10 and random state will be 100. So y k-means equal to k-means dot fit predict data transform. So we'll be adding prediction column to the dataset. So we'll assign our dataset as a new name, liu underscore new data is equal to liu data dot drop data liu data dot drop remis. So we'll be dropping remis column and assigning the set name as liu new data. So now liu new data new cluster equal to k-means dot label. So we'll be adding new cluster line in our dataset. So new cluster line will contain the 0 as cluster 1 and 1 as cluster 2. We'll be using dot head function to print the dataset. So as you can see, new cluster line is lm added, 9 column is added now. So let's plot the two cluster visualization. So for that one, we'll be using plt.scatter. So data transform, and s equal to 100. First cluster will be assigning cluster 1 as green color. Second cluster will be using red color for cluster 2. And centroid points for the older data set will be assigned as yellow. So now we can see the two cluster visualization as below. So cluster 1 is assigned as green data points, cluster 2 is assigned with red data points, and centroids will be assigned with yellow data point. So key insight from clusters. As per the visualization in cluster As per the visualization in cluster 1, which is green, we can see that the data points are spread very far from each other. Data points present after -3 on x-axis can be anomaly, as you can see from the plot. Data points in cluster 2 red are spread evenly in the visualization. We can see there are no anomalies present in cluster 2. Centroids of both clusters are presented by yellow color. Thank you.